Hello everyone. In this video we are going to learn how to import a digital source into EAGL. So when you open EAGL software, you can see the first page is a control panel of EAGL, which shows here. So go to File, New Project, and then make a new project. You can name it, for example, my project 1. And then while it's highlighted, you can add new schematic to it. So in this case, a folder called My Project 1 would be made under your project folder in the EAGL, where the EAGL is installed. And then all the relevant files, like this schematic file, would be saved in that folder. You can also save an Excel file inside that folder and then call that Excel file to load your desired patterns for your sources. So here I just make a source by add part. Because you want to use this source for the simulation, then you have to import the files from the ngSpice library. So you search for the ngSpice digital library here, and then from this digital library, select the digital source you want. So here we have 3 options for digital source. The first one is with 1 output, and then the next one will be 4 and 8 output. So for now, we can select this 1 output, and you can place the part. Just press escape 2 times or go to another part so that you have only 1 sample of it. So you can add a net to it also. So make sure this green bubble comes up here to connect the net. So this net is like a wire in your circuit, right? So you can right click on it. When it's highlighted, you can select the property and then change the name of the net. By default, because this is the first net in your schematic, is N1, but you can change it to another name. For example, out, right? So this is the name of the net that appears here. It's good to add a label also. So here is the label. You can select this line, and then you can see the name of the net appears here. Now we can add a probe also with voltage probe, and then this is the digital value that the output that you would be able to see after simulation. With this zoom to fit and zoom tool, I like this zoom to fit because you can zoom in and then you can see all the components. So the next step is to adjust this source. This source can generate any patterns of 0 and 1s. You have to determine at what time you want it to be on, what time to be off, and so on. So assume we have one pattern with 0 and 1s, just a pulse, right? So you can select this source and then click on digital source setup, or alternatively you can click on this icon and then select your source. And you can see that digital source setup appears here. So determine the time you want and then to see the changes. So here we start at time 0 with the initial value of 0. And at 1 millisecond, we want it to go to 1, right? And then at 2 milliseconds, you want it to go to 0. At 3 milliseconds, you want it to go to 1 again. So it's a pattern with only 4 rows, right? So if the pattern is quite simple, like this, you can enter it manually here. If it's a long pattern, or you prefer to save it as a CSV file, you can save it in Excel, for example, with the CSV extension, and then you can load the CSV file here. So after you do this one or load the CSV file here, you can save the setup. So now your file is ready. You can run the simulation here, and while you're running the simulation, because you're interested in the changes of the file during different time, you want to look at the transient behavior of the circuit. So you need to select it and you need to show what is the start time, what is the stop time. We want to see from 0 to, let's say, 3 milliseconds. Right? And then you can keep all the other values unchanged and simulate it. So when the simulator starts, you can see the value. So at 0, you put 0. At 1 millisecond, you put 1. So the value that you put in that table shows the new value at each time. Right? So at 2 milliseconds, you want to go from 1 to 0. At 3, we go to 1. So if I look at another value, for example, 4 milliseconds, you can see the other change as well.